All right, Aliyah, if I have a line, right? Mm, how was finding gradients? If I have a line, how would you find gradients?
Um, you have to read off your points.
How much points?
2 points.
Yeah, we just say I take this point and this point. What next?
Mhm.
Let me just say that this point over here, this point is x1, y1, and this point over here is x2, y2. Yeah, what next?
You use the
What formula?
formula to find gradient.
What's that formula?
X2 minus x1 over
Nah, nah,
y2.
you're mixing it up. You're mixing it up.
X1 minus x2.
Nah, it's y2 minus
Um,
y1.
yeah. Y2 minus y1 over x2 minus x1.
Our January exam was just the other day, you know.
I know.
Did you put any exam? X2
No.
minus x1? Okay.
Mm-mm. No.
So let we try to understand what y2 minus y1 over x2 minus x1 is. Do we understand what that means? Aliyah, this is the what? This is the what and y. Try to fill in the blank. The what and y.
The
If
difference.
the difference I like that, I want to hear something else. So that's what C. Difference is good. That's correct. But I want to get a specific word out of you. So that's what C. Amy, Nicholas, I'll give it a chance. That's what C.
Is it CO?
CH. So if you minus 2 points, if you minus 1 point from the other point, you're finding the what? That's
Change.
what the change. Right. Aliyah, let me just say Y2. Let me just say in year two you was 50 and in year one you was 20. What's the change there? You changed by how much?
2 years.
Right. So gradient is actually the change in Y, the change in Y over the change in X. And let me ask you a question. What do you think dy over dx means?
Derivative of y over the derivative of x.
No.
The
Nah.
difference.
Yeah. But specifically, it means the change in y with respect to the change in x. Is the same thing as gradient? Did I know that before? Nicholas, did you know that?
Um,
Well, now you know. dy over dx, d means difference or change in y over the change in x. So when you find gradient, you're finding for the first derivative, vice versa. So when you differentiate a function, you're finding for gradient. Now you know. dy over dx means change in y with respect to x. If I had dt over dv, what I mean? T is time and v is velocity. Alia, what does dt over dv mean?
The change in time over the change in velocity.
Now, I want you to say the change in time with respect to velocity.
Okay.
Change in time with
With
respect,
respect to velocity.
right. So differentiation is just a change we're finding for. So let me give you an example. You notice in the syllabus, you have to link it back to displacement, time graphs, and velocity and such. What do you all think? Okay, so I want somebody to tell me the formula for speed or velocity. Speed slash velocity. What is the formula? Nicholas, it's formula for speed slash velocity.
distance over time.
And velocity then would be the change in distance over the change in time.
Yeah.
So that'll be ds over dt. Velocity, Alia, do you know that velocity is displacement over time?
Mm-hmm.
You sure you know that?
Yeah.
Okay, well, velocity could be written as ds over dt. If you have the function for velocity in terms of displacement and time, you can differentiate it to find velocity. sorry, if you have a function for displacement, like displacement is equal to something, you can differentiate that function to find velocity. Because velocity is just the displacement changing with respect to time. You're probably confused. Um, when I say displacement changing with respect to time, asking you how much you're moving in 1 second, how much you're moving in an hour. You understand what I'm saying? It like if you see 50 kilometers per hour, how much you're moving per hour? If you see 50 kilometers per hour, how much are you changing?
50 kilometers every hour.
Right. So the distance is changing with respect to the time. And that this means ds over dt. So that's differentiation. I'll make a nice little note about it. Amy, let me know if you catch.
Yeah.
Right? Nice. So what exactly is differentiation? Let me use a nice pink color here. It is so I'm going to show you some instances, right? So, an example of differentiation, example dy over dx. This means the change in y with respect x, right? Funny enough, formula. Yeah, Amy, just remind me, what's the formula for gradient? Normal formula, you know? Amy, what's your regular formula for gradient?
Y2 minus Y1 over X2 minus X1.
And as we discussed, y2 minus y1, you're finding the difference between 2 points. So that's the what and y. That's what C. That's the okay. If in year two it was 50 and in year one it was 30, how much did you change by? Amy? If in year two it was 50 and in year one it was 30, how much did you change by?
20 years.
So that's the change in years. So anytime you have a difference between 2 points, that's a change. So funny enough, the formula for gradient is equal to y2 minus y1, which means the exact same thing. This also means so I want you all to copy this down and I'm gonna go into the basics of differentiation. Right, so as soon as you all have that copy down, let me know.
I'm finished taking it down.
Okay, nice. So Amy, I want you to look at how we would differentiate x to the power n. And what x to the power n is just a polynomial, like x to the power 3, x to the power 2. And if you wanted to differentiate that, you would pre-multiply the function. So I would multiply the function by the power, and then I would minus 1 from the power. So try differentiating x squared. So if you want to differentiate x to some power, you multiply by the power, and then you minus 1 from the power. So try differentiating x squared. Try that. Amy, there.
Wouldn't it be 2x to the power 2 minus 1?
That's correct. That's correct. And 2 minus 1 would just be 1, so that would just be 2x. Yeah. So what do you think the first derivative of um 2x would be? First derivative of 2x. That's a kind of tricky one. Aaliyah, did you copy down everything?
I almost and basics.
Okay. So Amy, if I have 2x, what's the power of x? What's the understood power of x?
1.
Nice. So you multiply 2 by 1, 2, then you minus 1 from the power. What is 1 minus 1?
2.
Right, so 1 minus 1 is 0. Anything to the power of 0 is?
1.
Right. So your final answer will be 2 by x to the power of 0, and x to the power of 0 is 1. So 2 by 1 is 2. So if you differentiate 2x, the answer is just 2. You catch?
Yeah, I kind of understand.
So if I differentiate 5x, what will be?
Like, 5.
Right. So let me ask that question.
Mhm.
If I differentiate 2, if I differentiate 2, I think I'll go.
2x.
Nah. You move it into the realm of integration. Um, the answer will be 0. If I differentiate 2, since there's no change, it's 0. Because 2 is a constant, isn't it?
Oh, yeah. Mm-hmm.
I will explain further just when everybody have that copy down. Right, so Alia, as soon as you have that copy down, let me know.
I done.
Nicholas, how about you? I have a feeling that you were finished long time ago.
Yeah, I finished on time.
Um, Alia, I had to play catch up. But Alia, I'm sure your notes looking much neater than Nicholas, so I'm sure. I'm positive.
Um, yeah,
Yeah.
me too.
Right. So let's do a couple examples of basic differentiation. Let's differentiate x to the power 3, right? So if you want to differentiate this, so let me just say d dx x cubed. So you want to differentiate x cubed. How will we do that? Tell Malia, how would I differentiate that? As per the formula.
N would be
3.
3.
So you take any power, you multiply
So,
any power, and then you minus and 1 from the power. So you multiply the whole thing
so
by
it
3.
would, so it'd be 3x to the power 2.
That's correct. Let's try another example. All right. How would I do this one? 2x to the power 4. Ah,
Um, you're multiplying 2x by 4. So
correct.
that's 8x. And 4 minus 1 is 3. So 8x to the power 3.
Nice. Emi, let me know if you catch that.
Yeah.
Nicholas, this is easy thing, right?
Easy.
Yeah. Right? This is not the only way they could ask you to find the first derivative. It could also look like this. So let's just say they gave you a function. Can we all agree that these here were not exactly functions? They just wanted to find the first derivative. But what if they bring a question like this? Let's just say they have y is equal to some x2. Let's just say they have y is equal to x to the power 4 plus 3x to the power 2. If I want to write the first derivative of this, it's going to be different. So Amy, and to agree we have a function here.
Yeah.
So if I am differentiating this, it will be the change in y, because y is a function, with respect to the x, because and if I change the x values, the y value will change.
Yeah.
So y is changing with respect to x. So if I'm writing this, I'm going to write dy over dx, because y is changing with respect to x. Aliyah, what is this? Aliyah, what's that? Y is equal to x to the power 4 plus 3x squared. That's what f. It's a
A function.
okay. It's a function. Do you agree then that different values of x would give me a different answer? Like if I put 1 into the function, okay. If x is 1, what would I get as my answer? If x is 1.
Um, it will be
1 to any one to any power is 1.
um itself.
Right. So 1 to the power 4 is just 1. Plus 3 by 1 to the power 2 is just 1. So 1 plus 3, which 1 plus 3?
4.
Right. Let me try it for a different value of x. Try it for 2 now. Try x is 2. You gotta plug in that into your calculator. Okay, all right?
Yeah.
Where you get your answer? Are you confused with what's putting into the function?
Um, X is 2,
Right.
right?
X is 2. So wherever you see x, you put it in 2.
So, I get 28.
28 is correct. So when x was 1, we got 4. When x is 20, oh, sorry, when x is 2, you got 28. So is y changing with x?
Mm-hmm.
Is y changing
Yeah.
with x? It is.
Yeah.
Because when x was 1, you get a different answer from when x is 2. So
Yeah.
that's what going on. We need to figure out the rate of change. We need to figure out how it's changing. So we need to figure out dy over dx. So the change in y over the change in x. If I differentiate x to the power 4, what would that be?
That'll be 4x cubed.
Right? And if I differentiate 3x squared,
It'll be 6x.
nice. Um, let's see how this would go. So another form they could bring it in is f of x, right? F of x. So they could say f of x is equal to minus 2x to the power 4 minus 3x to the power minus 1 plus 2x squared. Things sound look a little weird, right? Nicholas, tell everybody, what is the notation for the first derivative of f of x? Is it dy?
Notation.
Is it dy dx? Is it d dx?
E over dx.
Nah. If they give you your function denoted by f of x, then the first derivative you have to give it as f prime of x. Did you know that?
I did not know that.
Yeah, so right now I'm showing you all the basics and the different ways they could they could bring the question. So they could ask you for ddx. They could give you a function in terms of y and x, and then they could give you f of x is equal to something, right? So this is the first derivative, this is the first derivative, this is the first derivative. All these are the first derivatives. So Nicholas, how would I differentiate this?
So, operating from the one from the other.
Wait, so Amy and Ali, I want us to be doing this question in the meantime. I'll let you do this. Yeah, so Nicholas, tell me.
Right, so take the 4 from the power, put it on the 2, minus 2,
So say 4
and
minus,
minus 1.
tell me that's what you're saying. 4 minus 2, is that what you're saying?
Put the minus 2 in brackets, minus 2x to the power 3. 4 by minus 2x to the power 3.
Right?
And You can't put the x inside the brackets. So
Say that again?
the x don't have to be inside the brackets with the minus 2.
No, doesn't have.
Alright. Well,
If you're doing that,
minus 3.
it might confuse you with power answer.
Alright.
Because
Okay.
what you're really doing is you're taking the power and you're multiplying it by the coefficient of x. So 4 by minus 2 minus 8, then you work with the power parts. So 4 by minus 2 is minus 8, and then you write back x and you take away 1 from the power. That's always good. All right, so what next?
Yeah. Alright. So for minus 3x to the power minus 1. You're still taking away 1 from the power, so it'll be minus 2. And put the minus 1 by minus 3x.
Right.
Minus 1. Minus and minus 2. Okay.
Okay. So let me just give,
Alright. So
yeah.
yeah. So for the last one, you're taking away 1 from the power, so it'll be 2 multiplied by 2x to the power. Well, 2 multiplied by 2. Now, we get
So you see this whole line? We could do all of that in our head. Then they're not gonna give you extra marks for this. So we could actually jump straight to the answer. But 4 by minus 2 is minus 8 x to the power 3. Right? Minus 3 by minus 1 plus 3 x to the power minus 2. Last one, 2 by 2 is 4. 4x, take away 1, 4x to the power minus. So 4x to the power 1. Right. Um, Aliyah, let me know if you're confused. Again, this line is optional. You don't have to put this line, you can jump straight to the answer. Tell me.
No, I understand.
Okay, cool. Like this bringing back PTSD, like flashbacks. And you did this in school. And you did this in school already, Aliyah?
Yeah.
Yeah. So let me give you all one to try yourself. So given the function f of x is equal to minus 7x to the power minus 2 plus 3x to the power 2 plus minus. Yeah, so I want you all to try to not factorize. I want you all to try to differentiate this. Yeah, so right now I want everybody to be trying question 5. Try to differentiate that. Ah, so Amy, checking it out. So you differentiate minus 7x to the power minus 2 correctly. You differentiate 3x squared correctly. And the last one, check that back. If the minus 3 is multiplied by the minus a half, a minus by minus is a plus. See, I have minus. Amy, just the
Oh
last,
yeah, I just remember to make that mistake.
just that. Right, so I'm waiting on Nicholas and Leah. Yeah, that's correct, Leah. Just Nicholas now.
Gonna my camera quality not working too very.
Yeah, what? Call all your answer for me. Tell me exactly what you write.
Alright.
Exactly what you write.
14x to the power minus 3 plus 6x
Wait,
plus 3 over 2x to the power minus 4.
wait, what is on the left hand side? What's on the left hand side?
14x to the
Nah.
power minus 3.
Did you write dy dx? Did you write d dx? Did you write f prime x? What did you write?
I skip
No, you have to write f prime x. Otherwise, we are finding for. We know. You have to put f prime x. Yeah, f prime x is equal to.
here.
Tell me.
So prime x equals to 14x to the power minus 3 plus 6x plus 3 over 2x to the power minus 4.
3 over 2x to what power?
Minus 4.
Okay, cool. So now, so now that you all see different ways they could ask the question, they could say d dx, they could, you might have to write dy dx, f prime x, f prime x. Let's look at a slightly different situation. What would happen now if we differentiate a constant? What would happen if we differentiate? Oh yeah, you can tell me where's a constant?
Um,
What is a constant?
you know, mine. Mm,
I want somebody to tell me what is a constant.
a number, a
Yeah,
number by itself.
yes. A constant is just number by itself. So let me ask you a question. If if we have y is equal to 5, is there any x term over here? Alia, you seen any x over there?
No,
No. So then would y change with respect to x?
yeah, it will just be 0.
No.
Or no.
Yeah, well, say again. Let me look at
Like
this.
when you
Tama, you were saying something.
no, like when you differentiate, it will just be 0.
It would just be 0. But let me understand the meaning of that.
Yes.
Have any x here?
No.
So if they say x is equal to 1, are we plugging that in anywhere over here? Is there,
No.
is there any place to plug in that?
No.
Our x is equal to 2.
No, it wouldn't have anywhere to go.
So let me ask you a question. Does a gradient, right? Remind me, what does gradient mean? What does dy over dx mean?
The change in y with respect to x.
So if x changing, does y change in this? It have any
No.
dx? It don't have
What
any.
was that?
It don't have any way you could put the x, right?
Mm-mm.
So no matter what x is, would it affect this?
No.
No, that's why we call it a constant, because it's constant. It is not affected. So there's no change in y with respect to x. You could say anything. X could be anything. It wouldn't affect y. So the change in y over the change in x is zero. To differentiate any constant is zero because you don't have any way you can put the x. So the x do affect the y value. Amy, does that make sense? Make sense?
Yeah.
So let me understand that one more time. Nicholas, look at this example over here. So I was saying the gradient is the change in y with respect to x. What that means is if I change the value for x, what will change?
Y.
Y would change as well. Over here, if I say y is equal to 5, x could be anything. Would that affect the y?
Nah.
Nah. So then they have no change. Y does not change with respect to x. So the first derivative is zero, right? And remind me, guys, if the first derivative is zero, it means that the what is zero. So that's with g. The first derivative is the same thing as the. Oh yeah, remind me. The first derivative is what does the first derivative mean? That's what g. G.
The gradient.
Right. The first derivative is it means the gradient. So if I had an axis over here, it's yeah, if I had a pair of axes, I'm gonna show you something. And I'll leave on to the next thing. Yeah, so Leah, if I have a function y is equal to 5, how does that graph look like? What does the graph for that look like? Is this the graph for y is equal to 5?
No.
What about this?
Yeah.
It's sounding very unsure right about now. Everybody who agreed that that is the line y is equal to 5, and I'm on Amy,
Me.
is that the line y is equal to 5?
Yeah.
We know the subway gradient of it.
Um,
Is that
a
perfect?
0. It's any,
Whoa,
straight.
whoa. And what gradient of it is also happens to be 0. So what I'm saying is dy dx means gradient. Anytime you find the first derivative of a function, you're finding for the gradient. You're finding the gradient function. Um, Nicholas, any gradient of a flat line is 0.
Yeah.
Gradient is how steep something is. If it's flat, then it's not steep at all. Um, so if we had f of x, right? Wait, let me just change the color for this. Okay. I want you all to try to differentiate this function. Try that. Right, so try question two then. Okay, so your answer is correct, Amy. Nice. So you see how you wrote plus zero? You don't have to write plus zero. You can just leave it out. Yeah. Yeah, that's correct, Nicholas. Nice. I like how you put the F prime accent in. Cool. I just
Yeah.
searched Arabiano. Okay, cool. So nice. Everybody on the same page then. Right. All right. So if I so Amy, wait on me. Amy, if I tell you that the equation of a line, so I'm saying that the equation of a line is y is equal to 5x plus 3. In regular maths, just by looking at that, where's the gradients?
Five.
Okay, but now we know some new tricks. How can I find ingredients of this using odd maths? I would find the what?
The derivative of it.
Derivative.
Mm.
Yes. First derivative. So, so the equation of a line is y is equal to 5x plus 3. States the gradient. Right. So from maths, we know y is equal to mx plus c. Therefore, the gradient is 5. We know that. Awesome. We know m is equal to 5. But let we solve it from an odd math standpoint. In odd maths. Right. So Aliyah, if I find the first derivative of y, since it's y is equal to 5x plus 3, how would I write the differential notation for that? Y is equal to 5x plus 3. How would I write the differential notation for that?
dy over dx.
And we have 5x plus 3. The
So
difference
that is
x.
5.
Nice. See, it does work out. That's because dy over dx means gradient. And you find the first derivative, you find ingredient. Is that is everybody acquainted now? Like Aliyah, when you find gradient, wait, so when you find the first derivative, you're finding for the what? What function are you finding for?
Dy function.
The gradient function.
Mm-hmm.
That confusing, yeah.
No.
So y is equal to mx plus c. Y is equal to 5x plus 3 in maths. We know the gradient is 5. When we differentiate that, what we get?
5.
So we got the gradients.
Yeah.
When you find the first derivative, you're finding for the
Gradient.
yes. Finding for the gradient. Don't forget that. Amy, Nicholas, don't forget that. Right? Now, let me move on to some more troubling matters. We're going to move on to some troubling matters. A curve. What is a curve? Amy, what is a curve? Could you define a curve?
I don't know how to define a curve. Mm.
I want you to describe a curve for me in terms of gradient. So let me explain. A line, you would say a line has a constant gradient because in a line, the gradient is the same throughout, have the same steepness for a line.
Yeah.
Okay. For a curve, you think that's the same thing, you think the same thing is applying? You think the gradient is the
Mm.
same points?
No.
No. So let me look at a simple curve. Simple curve here. Okay, Aliyah. Nth gradient is the level of steepness.
Mm-hmm.
Would you say that the okay, let me just take this point over here. What's the steepness at this point?
3?
Three? Three.
I don't know. Yeah.
Steep. That's a gradient. What's the gradient at this point?
3.
Okay, Amy, what's the gradient at this point? Amy, Nicholas, what's the gradient at this point?
Here.
Zero, yes. Aliyah, check it out again. This is a straight line. What's the gradient of a straight line? Like a flat horizontal line.
0.
So I think Ali would have done this in maths. Remind my guys, in maths, how would you find ingredient of a curve? If any of y'all remember, how do you find ingredients of a curve in maths? Does anybody remember? Amy, do you remember how to find ingredients of a curve in maths? Amy, you hear me? Nicholas,
Yeah.
do you remember how to find ingredients of a curve in maths?
Is not with the tangent, aren't it?
Yeah, that's itself. That's itself, right? So to find the gradient of a curve, you have to draw the tangent at a point. So, Aliyah, let me just say we wanted to find a gradient at this point. I would have to draw a tangent to that point, and then I would have to take 2 points from the tangent and find a gradient using that method. You following?
Yeah.
Aliyah, let me just set a couple things straight. In a curve, do you think the steepness is the same throughout? Think of it like a hill. Think of it like a hill, right? If you're in a car and you're going up the hill, would this point be as steep as this point?
No.
Um, would the steepness at this point be the same at this point? Tell me, let me hear.
No.
No, it would not. And if you had to go up this hill and take up a rail strain on the engine to go up,
Yeah.
and the car would just like fly down though.
Yeah.
The gradient had to be different. This is a what kind of gradient? Positive.
Mm-hmm.
If the gradient is going in this direction, positive or negative.
Positive.
Positive. And the gradient in this direction is negative. And if you have a gradient like this, the gradient
Mm-hmm. Is 0.
right. So imagine in a car and you're going up the hill. Well, the gradient slowly decreases and you end up at the flat spot on top, 0. And then you start to go back down, the gradient gets more steep. So the gradient of a curve changes throughout. We could agree on that. It's not the same. Tell me if you agree with that.
Yeah.
Aliyah, can you agree with that?
Yeah.
So can you use y2 minus y1 over x2 minus x1 to find the gradient of a curve?
No.
No, because that's for a line. This is a
Yeah.
curve. Um, a quick exercise. Could any of you all in class figure out the equation or the curve? Hmm. Nicholas, you know how we would figure out the equation of this curve?
Um, I remember
Hmm.
the roots of its root or
Yeah,
something.
yeah, we had the roots. We had the roots. You can use your roots to find the equation of the curve. So x is equal. What is the two values for x?
Um, the x we have -2 and 2.
So let me show you what we could do, right? We could move across our plus two, move across our other two, and then we could multiply them. You realize we're doing factorization by in reverse, right?
Yeah,
Yeah. So we're working in reverse to get back the equation of the curve. So expand out from a quick and tell me the equation of the curve.
right. X squared minus 2x, um, 2x plus 2x, and then -4.
Right? What is minus 2x plus minus 2x plus 2x?
It just be x squared -4.
So that is the equation of this curve, right?
Yeah,
Right? So f of x is equal to x squared minus 4. Amy, you understand how I did the reverse to get back the equation of the quadratic? Tell me if you understand that.
Yeah, I understand.
Nice. Because if you wanted to figure out the roots, you would equate the equation to 0, and you'd factorize, and you'd find for x. We just did the opposite. Just did the reverse. All right. So let's try something. Let's try something, shall we? Uh, this is not a this diagram of it is not a scale. So, hmm, thinking. It's really not to
just
here what? Alia, at the what do I call this point here from maths? If you do some in art maths, this is the what point do I call this? What point would I call that? What's the name of this point? Anybody? What's the name of this point? Nicholas, Amy, this point over here. I have several names for it. Everybody's really quiet. Amy, you okay?
That's the maximum point.
Right? Maximum point or the turning point. And we know that the gradient at that point is
0.
0. So let me see if this is the actual turning point. Let me see. I'm curious. I just do a sketch over here. It's nothing too accurate. So Amy, if I wanted to prove that 3, 0, that 0, 3 is the turning point, let me show you how we would do that. At the turning point, what's the gradient?
0.
0. And we know the function. So let's find the first derivative of f of x, and that will allow us to find the gradient at any point. So differentiate x squared minus 4 for me.
That will be 2.
2 what?
when you differentiate -4, it would just be 0.
Yeah, but when we differentiate x squared, you wouldn't just have 2.
Or, wait, 2x to the, well, 2x, right?
Yeah, 2x. 2x, that's correct. Hmm. Wait, I'm looking at something. Okay, yeah, this would make a lot more sense. Yeah, this gonna make a lot more sense. That's the bad thing about coming up with these questions. Uh, okay, let me see if this works out. Yeah, so we end up with f prime x is equal to 2x. Okay, just confirm. Right. So, Amy, we have a gradient function. F prime x is equal to 2x. And at the turning point, at the turning point, what is the gradient?
0.
Correct. So you would say 0 is equal to 2x. So if that is the case, what is the x value at the turning point?
Um, 2? No, 0.
0. And if
Yeah,
we x, how could I
0.
and if I have x, how could I find for y if I have x? Is there a function we could use to see how um y changes with respect to x? Is there a function?
Yeah, the f of x is equal to x minus 4.
If I plug 0 into that, what would I get for y?
Um, you subscribe -4, whatever the turning point is. Yeah.
Correct. So the turning point would be 0 minus 4. Kind of this actually is another topic, eh? This is another subtopic. I cannot jump back a couple steps there, but I just showing you how it works. Previously, we saw how the first derivative gives us a gradient. Now we could use it in questions like this, where you're trying to find for the turning point, because we know the gradient of the turning point is 0. So you can make an equation and find the points. But let me stick to a simple example first. A simple example, right? I don't want it to get confused. Let me stick with a simple example first. So we have a curve here, and the function is x squared minus 4. Cool. That's cool. How would I find the gradient at this point? Aliyah, how would I find the gradient at this point? Let me just say at x is equal to minus 3. How would I find the gradient at x is equal to minus 3? Tell me, Aliyah, how would I find the gradient at x is equal to minus 3?
Um, you plug x into the function
Nah,
and you plug 3 into the function.
nah. This function here is relating y with respect to x. Don't forget, and f of x is the same thing as y.
Mm-hmm.
So
So,
is this a gradient function? Will this allow us to find gradient? This is the function on the curve. Eh? Are we going?
no.
No. What did we just now learn about the first derivative? The first derivative is the same thing as
As the gradient.
right. So when you find the first derivative, you are finding for
That's the gradient.
the gradient
The
function.
gradient.
Yes. So if I want to find a gradient at minus 3, I would have to find the first derivative of f of x. So what would the first
Mm-hmm.
derivative of f of x be?
Zero.
Nah, that's a
Oh,
differential.
differentiate. Oh, 2x. It would just be 2x.
Correct. So now that we have the function for gradient, we can now proceed. So first, first derivative is the function for gradient. And Aliyah, we just now discussed in a curve, is the gradient the same at all points? Is the level of steepness the same at all points?
No,
So will the gradient at this point be the same as the gradient at this point?
no.
No, right? As a matter of fact, the gradients will eventually get less and less steep because it's approaching zero. And when you reach this point, it flats. The gradient is zero when you reach that point.
Yeah, yeah.
Yeah, and we will see how that works out. So if I want to figure out the gradient at x is equal to -3, and this is how it would look like if Ollie wasn't doing hard maths and they wanted to find a gradient at the point, this is how you would have to do it. You would have to pull a tangent to the point and find the gradient of this line. Ollie, did you do that in school? Did you ever do that in school? To find the gradient of a curve in maths, you draw a tangent to the point and you find gradients of the tangent.
Yeah, I think so.
Yeah. But we doing hard maths now. We don't have to do that. We can just find the first derivative and plug it in. So I want to find the gradient at -3. So x is -3. So I would say f prime -3 is equal to 2 by -3. So Aliyah, when x is -3, what is the gradient? At x is equal to -3, what is the gradient?
-6.
Right. And again, if we have our gradient in this direction, what is positive or negative?
Going down,
Yeah.
negative.
And did we see for ourselves that it was negative?
Yeah.
Yeah. So I'm gonna write a little statement. The gradient at x is equal to -3 is -6. So I want you all to find the gradient at -2. What is the gradient at -2? So Aliyah, when you find the gradient at -2, should it be more negative or less negative? What do you think? -3 is over here and -2 is over here. Do you think the gradient should be more negative or less negative?
It would be less negative.
So the further down I go, the gradient is approaching what? What is the gradient approaching?
0.
Correct. So it should be less, 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 less negative. Let's see if that's true. So find the gradient at -2 for me.
It would be -4.
-4, that's correct. And you got less negative,
Yeah.
right? So I would say f prime -2, that would be equal to -4. Um, what is gradients at x is equal to minus a half. Hmm. Nicholas, I want you to tell me, what is the gradient at x is equal to minus a half?
X equal minus half. That is um
So where are we going to put that minus half?
minus a half of f is minus
Say that again, I'm not hearing you properly.
alright, so you put any minus a half
Yeah.
at I want to say put f inverse of minus a half, but
F inverse or F prime,
I mean f prime.
right? So we're going to say F prime of minus a half, and what will we get?
You would get um minus 1.
Yeah. And we notice about the gradient as we get closer and closer to x is equal to 0. We're noticing about the gradient. Watch. Minus 6, minus 4, minus 1. It getting closer to 1. What is the gradient getting closer to?
0.
Yeah. And that's because at the turning point, what's the gradient?
0.
Yep. Right? So, right? So f prime 0, that'll just be 2 by 0, which is 0. And that makes sense. So you see, for a curve, we can't just find y2 minus y1 over x2 minus x1. That's for a line. The thing is, with a curve, the gradient is changing at every single point. So you need to find the gradient function, which is the first derivative, and use that to find gradient. Simple. Right. So copy down what do you all have to copy down? And I'll come up with a question. Right, so copy this on. Aliyah, you have that copy down?
I joined the graph.
Okay. Why everybody sounding so sour today? Aliyah, you okay? Are you vexed out of wake up?
No, I just feel I'm kind of sick.
Oh, okay, okay, okay.
Yeah.
Amy, you have that copy down?
Yeah.
Okay, cool. So, Amy, how you find differentiation so far?
Um, it's okay. I just need to practice, I guess, you know.
Yeah, I know. I feel I was be like, you know, you know, you know,
Yeah,
you know. That's
no.
the thing. That's like if I ever hear anybody say now, think of you. Because like, oh, how about the art competition? And I remember I had something in UB, like in math fair. Oh, you know
Oh
that's
yeah. I'm not done.
how was it?
Yeah, it's going good so far. I already have like a sketch that I'm following. It's just a lot to finish, you know. I do next week, Friday.
Oh, okay. You coming along?
Oh, but I'm going. Hmm?
You coming along good?
Yeah. Oh, I'm going New on a field trip next week, Wednesday.
You going on a field trip
Yeah.
next to UB?
So you, yeah.
Oh, you might see me be there.
Yeah, so
Looking forward to UB though.
I when you in next.
Best of luck. Best of luck. Best of luck. Hmm. Think this pressure, yes? All right, so as soon as you'll have this copy down, let me know. I think I should have had it like copy down already. Like right now. Unless I stolen for time. Aliyah, stolen for time.
No, I like almost done.
Okay. Well, I'm gonna work on the question in the meantime. Aliyah, you seen everything on that screen?
Yeah.
Okay.
I finished.
Okay, cool. I have cups. Aliyah, I hear you saying anytime you hiccup somebody bad talking, yeah? Aliyah, you know about that?
Yeah. Yeah.
Aliyah, you probably want me to finish fast. Probably cussing in your head. Saying like, wait, hurry up now. I wanna go sleep.
No.
All right. So I give a question there. Is the first part, and the second part is find the coordinates. Find the coordinates of the turning points. Oh, bad. Aliyah, what you saying about me, boy?
It's not me.
Hey, you see what Bryce
I
right?
feel it's like what?
You see what Bryce writes on the eraser?
Yeah, I had right that actually.
I
I
thought
didn't I thought he had picked it up.
so. His middle name is Chidam or something.
No, that's his Rasi name. But on his birth paper it have that.
And people are not supposed to know your Rasi name.
Yeah, exactly.
Wait, boy.
I didn't even know he leave it, honestly.
I thought he write on some girl name or something on the eraser. I was like, that are real.
No.
So yeah. I wanted to try this question. I'm gonna drink some water. All right. Are you all getting true?
Yeah.
Amy, you there?
Yeah.
Excellent job. That's correct. I see you didn't get tired. Put the minus x.
So
That's because a lot of times when students do a question like this and they differentiate, the minus x might confuse them. But yeah, excellent job. That's correct. Next class, we're gonna look at the derivative as a limit. That's gonna be kind of hard, right? I'll wait on an answer from Alia and Nicholas.
I only do the first part. I didn't do the second part.
Try to figure out the second part though. I think you can. What did you get as the first derivative?
Um, for the first part, when x is equal to 1, I get 1.
Wait. You had to find the first derivative first. What did you get for the first derivative?
Oh, 2x minus 1.
Cool. So you get 1, 3, and minus 7.
Yeah.
Okay. Now figure out part B. You could find the coordinates of the turning point. What was the turning point? What we know about the turning point?
Um, the gradient of it is equal to 0.
Right? That's all you need. Figure it out. That's all you need. Okay, Alia, that's not what we mean. So, oh shucks, Alia, laptop died. Oh shucks. Nicholas, I don't think I got an answer from you. A and B.
Yes, and
All right.
I didn't know Kara was it.
What? Kira was here? Hey, Kira, just come here quiet, quiet.
I'm trying late because I sleep late. I'm sorry.
We moved class at 10 o'clock and you still sleep late? That's crazy. That's a little crazy. Wait, but it's good to have you nonetheless. It's good to have you. Um, Nicholas, yeah, that's correct. Nice. Nice job there. Right? So that's it for class today. Excellent job today, guys. Next class, like I said, we're gonna do a hard topic. It's not gonna be an easy topic. It's gonna be scary. How scary? Well, let me show you like a sneak peek. Um, Nicholas, I want to hear if you do it in school.
All right. Yay!
Yeah. Yeah, but do that in school? That had come in the
No, I
20
don't think
that had come in the 2024 paper and catch everybody off guard. So now I'm making sure to do it to my classes.
I, yeah. I never do this before.
A lot of teachers will do it. But it's come much. CSEC math, May 2024. Yeah. Let me get out maths. Where is it? Yeah. Watch.
Oh, I never see some others in my life.
So check it. Use the definition of the derivative as a limit to find f prime x for the function f of x is equal to x squared minus 3. Yeah.
Sorry for last year's C-section.
Yeah, yeah. I feel bad for them. I really feel bad for them. This was really unexpected. I didn't even do this on my class. And I didn't even do it in school.
Yeah, I remember doing this in school.
Yeah. And Miss Omatila Israel go through stuff. So surprise.
Yeah, she do everything.
But watch. Any syllabus it there. Check it out. Um, define the derivative at a point as a limit. The derivative as a limit, intuitive approach. What that supposed to mean? But I'm there, and I come in 2024, and nobody was expecting that. So like,
Yeah,
yeah, right? So that's it for class today, guys. I hope I didn't scare all you. I don't know what they're gonna bring in all yeah. I don't know. But I hope it don't come as bad as 2024. Yeah. 2024, the Real pull some stunts, boy. The Real do some
yeah,
things. All kind of thing they do in 2024. But yeah, right? So guys, have a blessed day. Later.
yeah, you too
Bye.
later.
Bye.